Hi, Mahalakshmi. I'm audible. Mahalakshmi. Yeah, okay. So we will wait for a few minutes to others to join. So if you have your friends, you can call your friends and tell them to join the class. Okay. How your class is going on, Mahalakshmi? Okay, let's start. Hi, good evening all. Welcome to Manorama Horizon free revision class. Today we will be dealing with matter in our surrounding chapter. Okay. So in this chapter, we will be dealing with, like, after the end of the chapter, you will be able to answer the following topics. That is, you will be able to answer physical nature of, sorry, So you will be able to answer for the physical nature of matter. Then characteristics of particles of matter. Then three states of matter. That is solid state, liquid state and gaseous state. Next, you will be able to answer changing states of matter. And lastly, you will be able to answer evaporation. So we will start with the physical nature of matter. Okay, Fatima, how are you? Let's clear all driving. So can anyone tell that, like, in our surrounding, many things are there, like many materials we are seeing every day. So they have different shapes, different textures, and different um, size also. Can you give some examples of daily life materials that you are seeing? Anyone? Fatima, Mahalakshmi, Vishnudev? No one? Okay. So in our surroundings, there are many things like materials. For example, we will see stone, then books, iron, many things like chair, table, everything. Like these are the materials. So these are called matters. So these have definite, like these have mass and occupy space. Substance or anything which occupies space and have mass are called matters. So here, matter is nothing but it's a substance which occupies space and have mass are called matter. For example, air, water, hydrogen, oxygen, these all are matters. Matters are mainly made up of tiny particles. So these matters have the space between the particle also and they attract each other. The other examples of matters are wood, air, etc. Okay. Then we will move to next slide. Now we will learn the physical nature of matter. So as I said, matter is made up of particles. can you tell how we can identify that matter is made up of particles? Good evening, Sri Raj, sorry. Okay. So here we can see, we can understand that how like matter is made up of particles. In earlier philosopher, they believed that matter is continuous as block of wood. See. Then later study, they have understood that matter is made up of tiny particles. Fatima, good evening, Fatima. Sorry, ma'am, I was attending the biology section. Oh, it's okay. No problem. So now we will see how matter is like, is matter is made of a particle or it's a continuous as block of wood. So for that, we have to take a spoon of sugar, and then water in a beaker. That water, like we have to mark the water level. We have to mark the water level, and then after marking the water level in the beaker, we have to add sugar in it, 1 spoon of sugar in it, and we have to stir it. After stirring, we can see only water in it, but there is no sugar particles. So where does this sugar particle went? Anybody have any idea? No one is responding. Why? What happened? Okay, I will tell. Okay. They dissolve in water. Sriraj, good Sriraj. Okay, John, into the spaces if what? Okay, yeah. So when we put sugar in water, they get dissolved and the sugar particles will occupy the space between the particles of water. Can you see this white colors? These are the particles of sugar and these blue colors are the particles of water. So from this we can conclude that matter is made up of tiny particles, that is particles. Even water is also made up of particles and sugar is also made up of particles. Now let us move to the next physical nature of matter. So next physical nature of matter says that particles of matter are very small. Okay. So this can be understood by the following activity. So we have to take 2 to 3 crystals of potassium permanganate, KMnO4. Then we have to take 100 ml of water in beak and we have to add 2 to 3 crystals of KMnO4 in KMnO4 means potassium permanganate in beaker containing 100 ml of water. When you add these crystals, the color of the water changes to purple due to the color of this potassium permanganate. So to check whether the particles of potassium permanganates are very small, we have to take 10 ml of this solution, that is into 90 ml of water, the beaker which contains 90 ml of water. Then we have to add this 10 ml of previous solution into the second beaker. Again, same thing we need to do. This 10 ml of solution we have to take and we have to add this 10 ml into 90 ml of water that is present in beaker third. So can you see there is a change in the color, like there is a fading of color. So in this first beaker, the color intensity is more. In second beaker, the color intensity is slightly less. In third beaker, the color intensity is more, slightly less. And in fourth beaker, the color intensity is less. So this tells that potassium permanganate crystals are made up of tiny particles. They can dissolve in any extent of water, and the color will be remain, but the intensity of color will reduce. So this indicates that the particles of matter are very small. Do you have any doubt in this? Anybody? No. Okay. Okay, Lakshmi. Sriraj, okay. Shall I move to the next class? Sorry. Next slide. Okay. Okay. Okay, Sriraj. So next we will see this question. Yes, okay. So who will tell answer for this? Which of the following are matter? Taste, okay. I'll allow you to speak, okay. Sriraj. Tell Sriraj.
Love, hate, thought. These three are the, chair,
Okay.
air, smell, almonds, and cold drinks. These are matters and the rest three are not.
Okay. Why these three are not matter?
Because they don't consist of any particles.
They don't have mass and they don't occupy space. Yeah, they don't have particles also. Yeah. Good, Sriraj. Next. Who said? Yeah. Christine, chair, air, almond, cold drink are particle. Sorry, matters. Okay. Next, we will move to the characteristics of particles of matter. As we discussed earlier, particles of matter have space between them. So as we discussed, when we put a spoon of sugar or salt in beaker containing water, that sugar or salt get dissolved and they form a solution. So in that solution, the sugar or salt will get dissolved. It means the particles of sugar or salt get occupy the space which are present in the particles of water. Is this point clear to everyone? Okay. Okay, Deepak. Next, we will move to the other slide. Next. Okay, Niranjan. Okay, Niranjan. Next, particles of matter are continuously moving. So it means they will not be at rest. They are continuously moving. So this can be seen by the following activity. So when we take an incense stick and we place it in the corner of our classroom, the smell will come. But when we go to near that incense stick, the smell will come. When we burn or when we light the stick, that incense stick, the observation will be different, because like when we light the stick, we will get to smell, like suddenly the smell will come. Means the particles of incense stick will spread more efficiently when we light it. When we are like it is without lighting, the particles of incense sticks will not move that as much that fast compared to when we light the incense stick. So this says that particles of matter continuously move. Without lighting also, we will get the smell of incense stick, and after lighting also, we will get the smell of incense stick. But the difference is that, like when we heat it, or when we increase the temperature, we will get the smell very fastly compared to the cold one, like without lighting. Okay. So we will move to the next slide now. So this intermixing, as I said, when we light the incense stick, we will get the smell of that incense stick. So this happens because the particles of incense stick intermix with the particles of air. That's why we get smell. And this process is called diffusion. Diffusion means the intermixing of the particles of two different types of matter on their own is called diffusion. So diffusion means intermixing of particles of two different substances. Now we will learn the diffusion in detail. Okay. And the diffusion is also depends on the matters, different kinds of matter or different kinds of substance. Let us take an example of ink, that is blue or red ink, and the honey. So we have to take two beakers. In one beaker, we have to put honey, like in both the beaker, we have to take water. In one beaker, we have to add ink slowly and carefully along the side of the beaker. And in next, we have to add honey into the another beaker. So what you will observe, the beaker in which we added this ink, the color of the beaker will become like the color spread fastly compared to the beaker which contains honey. This is because the density of honey is more compared to the ink. So diffusion is also depends on the density. Okay. Next, we will move to the interesting fact. So this diffusion of honey in water can be used to identify whether the honey is pure or not. For example, when we put honey in water containing a beaker, the honey falls in the form of streak. So if honey falls in the form of streak, then it is confirmed that the honey is pure. Okay. Next, we will move to the next property. Particles of matter attract each other. So here, as we know that there is some force between the particles of matter. For example, if we take an example of iron nail, piece of chalk and rubber, and we break them by hammering or cutting or stretching, what we can see. So when we hammer iron, like, we cannot easily break the iron nail because there is some force of attraction between the particles of iron. So that force of attraction between the particles of iron will not allow it to break very easily. So when we break this piece of chalk with hammering or cutting, it will break very easily because the force of attraction between the particles of piece of chalk is very weak compared to that of iron nail. So when we take an example of rubber band, when we stretch the rubber band, it will loses like the size will increases. But when we remove that force from that rubber band, it will come on the original size. So it means all of three have the force of attraction between them. But in iron nail, the force of attraction is more, means that is they attract each other very strongly. In piece of chalk, the force of attraction is less compared to iron nail. And in rubber band also, there is a force of attraction between the particles. Therefore, when we remove the force from the rubber band, it will regain its original shape. Okay. Next, we will move to the next part. So can anyone tell what are these? Anyone, like, do you have any doubt in? Okay, solid. Deepak, yes. Lakshmi, solid. They are in solid state. Yes, Sriraj. Anybody have doubt in characteristics of particles of matter? No doubt. Okay. Okay, Deepak. Okay, Sriraj. So, what you can see in this, does they have definite shape or distinct volume or distinct boundary in these images? Anybody? Yes. Why? Because they are solids. So now we will define what is meant by solid. They are in solid state. Yeah, Sriraj. So next is that a solid possesses a fixed volume and a definite shape. Some common examples of solids are wood, stone, common salt, sugar, iron, copper, etc. So now we will study the characteristics or properties of solids. So in solid, particles will be like this. Okay. So first we will study first property. Solids have definite shape and definite volume. Why solids have definite shape and definite volume? This is because the force of attraction between particles of solids are very strong and they have less space or negligible space in between the particles. So due to the strong force of attraction between the particles of solids have they are tightly packed, and due to their packing arrangement, solids have definite shape and definite volume. That is due to the strong intermolecular force of attraction, solids have definite shape and definite volume. Next, we will move to the next property. Solids are rigid. It means when we try to break a solid, it will break, but the shape remains the same because of the strong intermolecular force between the particles of matter. So, solids are therefore rigid. Next, we will move to the third property, that is solids cannot be compressed. So, this is because in solids, the intermolecular space is very small. We can say negligible also. Due to the less intermolecular space between the particles of solids cannot be compressed. Next, we will move to the next property, that is solids don't undergo diffusion. Diffusion, as I already told, diffusion is intermixing of particles of the two matters. Like this intermixing happens like when you have space, when any substances or any matter have a space in between the particles, then only intermixing of things happens. So that's why, like in solid, as we discussed, the intermolecular space between the particle is very less or negligible. They do not undergo diffusion. Okay. Next, we will move to the other section where we will find why these will regain its shape and all. For example, consider this rubber band. Here, when you, as we said, solids are hard, they have definite shape and definite volume. Ma'am, doesn't sugar diffuse in water? No, it diffused in water because sugar is soluble substance. It dissolves in water when we put sugar in water. It dissolves in water. Sugar is made up of many tiny particles. Sugar is a crystal. Understood? Sriraj? Okay. Okay. Next, rubber band. So when we stretch the rubber band, it will like the same shape of the rubber band will changes. Okay. Someone asked something. Okay. Nothing. So when we stretch the rubber band, it will change its size. As we said, solids have definite shape and definite size. But when we apply force or stretch the rubber band, the shape of the rubber band changes. Like it will become large. When we remove that force, the rubber band will regain its original shape. So, rubber band is a solid. It does not change its shape. When we stretch it, then only it will change the shape. When we remove that pressure or force, the size will it will regain its size. Next, we will see sugar and salt. So, as we discussed, sugar dissolves in water as well as salt also dissolves in water. They take the space between the particles of the water. Next is sponge. As we said, solids are non-compressible. But sponge is a solid, but it can be compressed. Can anyone tell why solids can be compressed? Like why sponge is compressible? Anyone? Though it is solid, it can be compressed. Why? Has air cavities in it. Yeah, John. Yes, due to holes having air in them. Yes, Lakshmi. It can return to its solid shape. No, Roshan. It has. Okay, someone texted again. No. Compressible means pressing. When we press something, it gets compressed. That is called compressible, Roshan. So here, can you see another image? Here in sponge, there are pores in the sponge. So in this pores, airs are occupied in these pores. When we press wait, because they have air holes in them. Yeah, Sriraj. So when we press the sponge, the air in this hole comes out and therefore it gets compressed. When we remove our hand or pressure, the air gets filled in that pores. So sponge is solid, but it is compressible. Understood, everyone? Do you have any doubt in this? Okay, Deepak. Yeah, Lakshmi. Okay, Shiraj. Thank you. Okay, let's move to the liquid state of matter. So, anyone can tell what are these? Can anyone tell? Water, milk, Lakshmi, Roshan, oil, Roshan, Amla. No, oil it is. Sriraj. Okay. It's oil, okay. Roshan, okay. So, here we can see that it is a liquid water. So it is flowing like here it is has no definite shape. Yeah, Niranjan, we'll discuss this. So here milk takes the shape of this glass, and here it took the shape of tumbler. Next. Okay. Here, this is oil in different 3 containers. So now we will learn the definition of liquid state. A liquid possesses a fixed volume but no definite shape. Okay, here the volume of liquid is fixed, but shape is not defined, because when we pour any liquid or water, for example, here we are pouring water from bottle to glass. So it will take the shape of glass. So when it was in bottle, it took the shape of bottle. Okay. So some examples of liquids are water, milk, alcohol, oil, etc. So liquid possesses a fixed volume but no definite shape. Okay. Now let us see the properties of liquid. As I said, liquids do not have fixed shape. This is because the intermolecular force between the particles of the liquids is very weak compared to solid. So due to this intermolecular force of attraction, the liquids do not have fixed shape. Means they have weak intermolecular force of attraction. Next, liquids flow and they are not rigid. As we said, the intermolecular force of attraction, they have space between them. Yes, Shiraj. First is intermolecular force of attraction. Intermolecular force of attraction is weak in liquid compared to solid. So due to this weak intermolecular force of attraction, liquids do not have fixed shape and they have more intermolecular space compared to solids. So they are not rigid because they have weak intermolecular force of attraction and the space between them is more. The liquids flows because of the space between them is more and weak intermolecular force. Liquid can be compressible. As I said, there is a space between the particles of the liquid. So the space in the particles of the liquid is more compared to solids, and liquids are compressible. Again, so in liquids, the particles are away from each other due to weak intermolecular force, and they have more interparticular space. Due to this space, diffusion is more in liquid compared to solids. We will move to the next slide now. So can anyone give answer for this? How do aquatic animals breathe? Can anyone tell? Gills. No, like for breathing, which gas is okay, important? Okay, John, good. My dissolve with gills. Oxygen dissolved in water. Okay, Roshan. Okay. Okay, Deepa, good. Oxygen, yeah. So there are again text. No, oxygen diffused in water. Yeah. So there are 2 gases that dissolve in water, that are carbon dioxide and oxygen, CO2 and oxygen. So the atmospheric oxygen dissolves in the water, that is water sources like pond, lake and sea, that get dissolved in water, and that oxygen is called dissolved oxygen. Dissolved oxygen. So due to the presence of dissolved oxygen in water, animal breathe. So for breathing, oxygen is necessary. So aquatic animals survive in water due to the dissolved oxygen present in them. Then how do aquatic plants prepare their food in water? Can anyone tell? Plants prepare their food by the process called photosynthesis. Which gas is necessary for photosynthesis? Anyone tell? Anyone can tell now? I am audible to everyone? Carbon dioxide. Yes, Anjali. Okay, Fatima. Good. Okay. How do aquatic plants prepare their own food? Sriraj, understood? The second question only. It is there in the slide. Okay. Yes, Lakshmi. Yeah. So as I said, carbon dioxide is also soluble in water. So this gas gets dissolved in water, and this dissolved gas is called dissolved carbon dioxide. Dissolved carbon dioxide. So plants make the use of dissolved carbon dioxide to prepare their food by the process called photosynthesis. So now we can see that gas also also dissolves in water, that is liquid. Solid also dissolves in liquid, and some liquids also dissolves in liquid. For example, milk is a liquid. When we put milk in water, it gets dissolved in water. So in liquid, like all the three states of matter get diffused in liquid. Okay, let us move to the next point. The gaseous states of matter. So as we know that our atmosphere is mainly consist of gas, like in that air is mainly made up of nitrogen, then oxygen. So air is a gas, helium is also gas, ozone is also gas, carbon dioxide. Air is a mixture of gases, okay. Helium, ozone, carbon dioxide are gas, and water vapor is a gaseous form of water. So it neither possesses a fixed like gas occupies whole volume of the vessel, which is it is placed. Common examples of gaseous states of matter are air, oxygen, hydrogen, carbon dioxide, etc. So these we cannot see by our eyes. These are like these in gases, the molecules are far from each other, so we cannot see these matters. So we will next move to the properties of gaseous states of matter. First one is gases are highly compressible. As you can see here, there is a lot of gas spaces between the particles of gases. So can you see there are many spaces, like large space between the particles of gases. So due to this spaces or more intermolecular space between the particles of gas, the gases are highly compressible. For example, take 100 ml of syringe, close the nozzle by, I'll show here. Close the nozzle by inserting a rubber cork. This is rubber cork. Then remove this piston, add in one nozzle, add chalk piece, and in another nozzle, add this water. Sorry, it's a syringe, sorry. And in third syringe, you have, so like it's already filled with air, no need to add anything. Try to, like, then put piston, then try to press the piston. In which of the three piston you can compress more easily? Can anyone tell? This is first syringe, second syringe. This is third syringe. Third, yes. Tisha, yeah. Lakshmi, yes. Lakshmi. Okay, third. This is because in third, air is present. As we said, in air, the intermolecular space between the particle is more. There are more space between the particles. So, due to the space, air can be compressed. Okay, so in third syringe, we can easily push the piston. Next, we will move to the another property of gas. So, due to, as I said, gases are highly compressible. So, in LPG, CNG cylinder, and we use oxygen in hospital, that is for artificial respiration, we use oxygen. So, this can also be due to the compressible properties of gas. For example, this like we can fill large amount of gas in any small cylinder by compressing this. So these are the because of the compressibility of gas. So we are getting this LPG cylinder, CNG cylinder, and oxygen cylinder, and it will last for many days. Next, we will learn another property of gas, that is gas exerts pressure. As we said, any particles of matter are continuously moving. So here, the particles of matter in gas, like the gaseous particles, are far from each other, and there is weak force of attraction between them. Due to this, they collide with each other, and also they collide with the container, all of the containers. So due to this, the pressure is exerted by the particles of matter. This is the pressure is due to the bombardment of the particles of matter with each other and the all of the container. So here you can see this, they are moving each other, like they are not at rest. They are like hitting the all of the containers. Okay, next we will learn gases diffuse very fast into other gas. As we know, there is large intermolecular space between the particles of the gases. Due to this large intermolecular space, the gases diffuse very fastly with other gases molecules. So diffusion is very high in gas compared to the liquid and solid. Okay. Let's move to the next topic. So these are the important characteristics of three states of matter. So as we discussed, solids have fixed volume and definite shape. Liquids have fixed volume but no fixed shape. Gas have neither a fixed shape nor a fixed volume. So like that, so these all are the properties of matter. So here, all the properties of matter are summarized here. You can check this, okay. Now let us move to the next. So, can anyone tell answer for this? Out of solids, liquids and gases, which one has minimum spaces between the molecules? Okay, solid Lakshmi, Sriraj, good. Only Lakshmi, Sriraj is replying, no one is replying. Out of solids, liquids and gases, which one has minimum space between molecules? Okay, let us see. Okay, Anna. Good, Anna. Yeah, solids have minimum space between the molecules. Okay. Niranjan, Roshan, yeah, good. Yeah. Hassan, yes. Solids, yeah. Okay, we'll move to the next question. That is, out of solids, liquids and gases, which one has maximum intermolecular force of attraction? Okay. Niranjan, it's a force of attraction. Maximum force of attraction. It's not maximum space. Okay. No gas. Liquid, no. No, Fatima. Intermolecular force of attraction is different. Intermolecular space is different. Maximum intermolecular force of attraction means in which state of matter the particles are compactly packed. It's solid, yeah. Solids have maximum force. Yes. Okay. So in solids, maximum intermolecular force of attraction is there. So last question is, out of solids, liquids and gases, which one has maximum movement of molecules? Can anyone tell? Maximum movement, yeah. Good. Gas. Yes, good everyone. Yes. Yeah. Gases have the maximum movement of molecules because the space intermolecular space between the particles of gases is high. Like it has more intermolecular space between the particles of gas. Hence, there is a maximum movement of molecules in gas. Okay. Gases. Okay. Yeah. Good everyone. I'm not able to read everyone's name. Okay. Everyone is replying fastly. I'm not able to see everyone's name. Okay. Let us move to the next question. Give reason for the following. A gas fills completely the vessel in which it is kept. Anyone? Why gas completely fills the vessel in which it is kept? Anyone? Because it has a lot of intermolecular space, yeah. It will move everywhere, because they can be compressed, no. Yeah. Okay, let us see the answer. Answer is, in gases, that as I said, the particles are very loosely packed and the force of attraction between the particles is very negligible. So as a result, they move randomly at any position, like at any direction. So therefore, because they keep moving in with the vessels. Yes, Sriraj. So sorry. The thing is, first is they are very loosely packed and force of attraction between the particles are negligible and they can move at random in all the directions. Hence, they can fill vessel completely. Next, we will move to the other question. The smell of hot sizzling food reaches you several meters away, but you get the smell of cold food. We have to go to close. When we have to go to close. Can anyone tell answer for this? The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food, we have to go to close. Can you tell the reason for this? Why we need to? Yeah, diffusion is there, but here hot and cool is there. No, hot and cool is there. As I said, temperature. It depends on temperature also. Can anyone tell? Kinetic energy is there. Yeah. Yeah. Yes, good. Sriraj. Okay. Yes, Mahalakshmi. I'm not able to read all the names. Okay. Okay. Sriraj, good. Deepak, good. Yes, good Lakshmi. Anna, good. This is near rapidly. Yes. Teresa, yes. Okay. So, as we said, diffusion is faster as the temperature increases. Here, see the smell of hot sizzling food reaches us quickly as compared to smell of cold. This is because the rate of diffusion increases with increase in temperature. Good all. Roshan also good. Okay. Then you'll move to next. Now, arrange the solid, liquid and gases in order of their increasing compressibility. Can anyone tell? Increasing compressibility between solid, liquid and gases. Which has highest compressibility? Okay. Yes. Gas is highest. It has the highest compressibility. Okay. Gas, liquid, solid. Yes, good. Good, everyone. So, compressibility of these three states of matter is in gases, the compressibility is more. The increasing order. In solid, the compressibility is very less. Compared to solids, liquid has more compressibility. Then, compared to liquids, gases have more compressibility. Okay, yes. Then we will move to next question. Arrange the solid, liquids and gases in order of their increasing density. Can anyone tell? Increasing order, okay. So the matter which has low density should, okay, be first, and the matter which has high density should be last. Okay, solid, liquid, gas. Okay, increasing order in the sense. Yeah. See, density here. Gases have low density because the particles in gases are not compactly arranged. They are far from each other. And in liquids compared to gases, the liquids have more density compared to gases. But in solids, the particles are compactly arranged hence these have high density. So increasing order of the density of the three states of matter is like this. Next, arrange solids, liquids and gases in order of increasing their diffusion. Diffusion, yeah, I'm getting charts. Okay. Yeah, increasing order. Okay, gas, liquid, solid. Yes, yes. Diffusion is more in solid, huh, Niranjan? Niranjan, no, okay, gas. It's gas, yeah. Okay, good, Roshan. So, here, the increasing order of diffusion is, the diffusion is more in gases compared to liquids and solid. Liquid also diffuses, but in solid, diffusion is not that much. Okay, next is fluidity. So, in this fluidity, the gases are more fluid than liquids, than solid. So, the increasing order of the fluidity of the three states of matter is this. Liquid, gases, liquid, solids. Yes, good, good everyone. Next, we will move to this change of states of matter. So, as we know that fluidity means they move faster, like they flow. As in water, we can see when we pour water in floor, they flow. Since here gas also flow, because in gases there is no like intermolecular space between the intermolecular force of attraction between the gases, molecules of gases. Oh, then it is gas. Okay, yeah. And the intermolecular force of attraction between the gases is very negligible, so they can move randomly. So gases are highly like fluid. Like we can say ki, compared to liquids, fluidity is more in gas. Next is change of states of matter. As we know that there are three states of matter: solid, liquid, and gas. So we also know that for changing from changing one state of matter to another state of matter, two important quantities are there, that is temperature and pressure. So, for example, by changing the temperature, we can change the states of matter from one state to another state. And also by changing the pressure, we can change the state of matter from one state to other state. Now we will see this by one, okay? Let us see the change of state of matter by changing the temperature. So, first we will see how solid is converted to liquid by changing the temperature. When, for example, take some few ice cubes and in a beaker and heat it. So while heating, you have to like observe the temperature in the thermometer. And when you start heating, the gas or the ice cube present in the beaker start melting. When ice starts melting, ice to water. When ice start melting, the temperature will remain same till it will completely become water. Okay. So when, see here you can see after like melting of ice to water, when again we heat this water, it will convert it into steam. But during conversion of water to steam, there is no change in the temperature of the thermometer. So we will discuss this also, why this is happening. So here, okay, one question. The temperature is used for breaking the force of attraction. Yeah, latent heat. Okay, yes, good. Good, Roshan. So here, solid to liquid. The process of conversion of a state of matter from solid to liquid is known as fusion or melting. And the temperature at which solid changes to liquid is known as melting point. Next, as I said, while melting, the temperature, like from conversion of ice to water, there is no raise in the temperature, because the temperature energy supplied by the heat is helps in the breaking of the intermolecular force between the particles of the solids, that is ice. So that energy is hidden. So that energy is known as latent, or hidden energy is known as latent heat, or heat is known as latent heat. So while this latent heat is observed from solid to liquid, then that is known as latent heat of fusion. So here, the latent of heat of fusion, you can see when ice starts melting till it becomes completely water, that there is no increase in the temperature, because the temperature or the heat is involved in the heat energy is involved in the breaking of the intermolecular force between the particles of the ice. Understood? This is known as latent heat of fusion. Do you have any doubt in this latent heat of fusion? Anybody have doubt in this? Fusion, melting point, or latent heat of fusion? No? Okay. Next, we will move to the another state. Liquid to gas. No. Here, liquid to gas. As I said, when we heat the ice cube, it will get converted into water. So here, when we heat water more, it will start converting from liquid state to vapor state. During the conversion of liquid state to vapor state, there is no increase in the temperature. Vaporization, yes, it's good. Vaporization, so there is no increase in the temperature during the conversion. When it gets converted to steam, then the temperature is increased. Here also, when it gets converted into water, temperature will start increasing. So this is known as the temperature, the same with solid to liquid. Yeah. So here, this heat is known as latent heat of vaporization. That heat is also involved in the breaking of strong intermolecular force between the particles of water. So that heat is known as latent heat of vaporization. Latent means hidden. And the temperature at which the liquid changes its from the substance changes from its liquid state to gaseous state, that the temperature is known as boiling point. So here vaporization is the process where the substance from its liquid state to changes to gaseous state. Okay. Next is scale to measure the temperature. Here there are 3 scales: Celsius scale, Kelvin scale, and Fahrenheit scale. So Celsius scale is measured in degree Celsius, represented in 0 degree Celsius. So it can be calculated degree Celsius is equal to Kelvin minus 273. Kelvin scale measuring in degree Kelvin, represented as K. Fahrenheit scale measuring in degree Fahrenheit, represented as F. So for calculating the Kelvin, K is equal to degree Celsius plus 273. For Fahrenheit, this formula is used. So now we will see how to convert following temperature, that is 300 Kelvin into Celsius scale. Here, as we know that degree Celsius is equal to K minus 23. The value Kelvin they have given is 300 minus 273 gives, anyone? 27. Yeah, good. 27. So similarly, we can calculate for other temperature also by using this formula. So for Kelvin, we can use this formula, and for Fahrenheit, we can use this formula. So we have seen by increasing the temperature, we can change the states of matter from one state to another state. That is from solid to liquid and liquid to vapor. So by reducing the temperature, we can also change the state of matter. That is, see here, when steam comes in contact with the cold surface, it gets converted into water, and that process is known as condensation. Condensation is a process where vapor state of matter is converted into liquid state of matter. When we freeze or we apply more, we reduce the temperature of the water, then this water is get converted into ice, and this process is known as solidification. The process of conversion of liquid to its solid state is known as solidification or freezing. Some common example is here. See, ice is a solid state of matter, water is a liquid state of matter, steam is a gaseous state of matter. So when we heat the solid, that is ice, it melts to form water. Then when we again heat the water, it boils and it will undergo vaporization and forms steam. Again, when we reduce the temperature of the steam, it gets condensed and forms water. Similarly, when we reduce the temperature of water or we freezes the water, it will get converted into ice. So by changing the temperature of the state of matter, we can change the states of matter from one state to another state. Now let us move to the how pressure can change the states of matter. Sorry, before that we will see what is meant by sublimation. So as we know that some compounds, that is camphor and all, when we keep outside, it will get the size of the camphor will get reduced. And for example, naphthalene balls also, when we keep it outside, the size of the ball will get reduced, or sometimes it will get diminished. So that process of formation of conversion of solid into gas is known as sublimation. Can we change solid into gas? And it's called sublimation. Yeah. So we can change solid into gas as well as gas into solid. We cannot change, there are some substances which undergo sublimation. So here, in this, we can see, we can take camphor when we make it a powder, and we have to keep it in a china dish, and we have to cover that china dish in with the funnel, and we have to close that funnel with the cotton plug. So when we apply heat or when we start burning this camphor will directly convert it into its gaseous state. So here vapor will be there. After some time, when it touches the surface of this funnel, it gets solidified, and we can see the camphor solids on the surface or all of this inverted funnel. So here, this is the process where The change of solid state directly to gaseous state without changing into liquid state is called sublimation. So the reverse process of sublimation we call deposition. So we cannot, like, there are some substances which get sublimated, like which undergo sublimation are camphor, then naphthalene, etc. Someone asks some question. I'll give your answer in next thing, okay? Change solid into gas. That in pressure, I will explain. The change of pressure, I will explain that point to you, okay? So next, we will learn effect of change of pressure. So when we apply pressure on any state of matter, the interparticle space between the particles of matter decreases. So thus particle matter can brought close together. For example, if you see, these are the gas molecules. When you press the piston, the gas molecule gets compressed. When you press more, the gas molecules become close together. So this is like we can compress, like by applying the force, the space of the particles get reduced and they come together. So we will see some example here. So effect of change of pressure. For example, liquefaction. Someone asked me who asked me? Roshan asked me, can we change solid into gas? Is it sublimation? No. Here we can change solid into gas, but by changing the pressure. So here, as you said, so solid carbon dioxide you must have seen. It is also known as dry ice. So this solid carbon dioxide gas get converted into, solid carbon dioxide get converted into gaseous state directly by decreasing the pressure to 1 atmosphere without coming into liquid state. We can change the state of matter, like we can change solid to gas by decreasing the pressure. So the next is that liquefaction. Liquefaction is a process of conversion of gas into liquid by increasing the pressure. So here, when we increase the pressure and decrease the temperature of any gas, it will get converted into liquid. For example, you can see here, it is not there. So LPG and all. So this, like, liquefaction is a process where the gas is converted into liquid by applying a pressure. That we can see in our daily life also. Like that example we can see. Next is evaporation. Here, can anyone give evaporation example? Like here, water when we left uncovered, it changes into vapors, but it will take time. So if we keep water in sunlight, the rate of evaporation is like increases. If we keep that water in room, we will see that the water takes time to change its state from liquid to vapor. So similarly, when we keep clothes for drying, it will also get dry up. Why this happens is, this happens because of the process of evaporation. So in this process, so evaporation is a process where change of liquid into vapor at any temperature below its boiling point is called evaporation. So there are some factors. Boiling water. I didn't got. I didn't get you. Boiling water? So yeah. So boiling water is vaporization. Here evaporation is the change of states of matter from liquid state to gaseous state below its boiling point. Here we will not supply any external heat. So this is called evaporation. Evaporation and vaporization both are different. Evaporation occurs by its own, like by absorbing surrounding heat and all. I'll explain the evaporation. I know the example for this. Loss of water from plant is transpiration. Loss of water from plants is transpiration. Okay, perspiration is sweat, yeah. But the common example is sweating, yeah. Common example is extraction of salt from seawater is by the process of evaporation. Okay. So next we will see the factor which affects the evaporation. So first, the factor which affect the rate of evaporation is surface area. Can you see here? This is a bowl like china dish and it is a test tube. So, for example, when we keep petrol in china dish and in test tube, the rate of evaporation is more in this and compared to this test tube. This is because the surface area, humidity, temperature, surface area. Yes, Roshan. The surface area of this china dish is more compared to the test tube. So here, the rate of evaporation increases with increase in the surface area of the liquid. See, surface areas. See, the first point is increase in the surface area, the rate of reaction increases. Sorry, the rate of evaporation increases. First point is the rate of evaporation increases with increase in the surface area. We will see next example. Sorry, next factor. So here you can see that this is winter, summer. So can anyone tell why the rate of reaction increases in summer compared to in winter? Can anyone tell? Heat, yeah. So as we know that increase in the temperature, the rate of evaporation increases. Here, the rate of evaporation increases with increase in the temperature. This is all because already like some portion of the liquids have the kinetic energy. When the temperature is increased, the kinetic energy of the liquid is become more like increases and it will overcome the force of attraction between the particles and it will changes into vapor state. So that's why increase in the temperature, the rate of evaporation increases because the temperature is more during summer. Yes, good. We will see next factor. So decreasing humidity. Humidity is the water vapor present in air. Okay. So when evaporation increases with the decrease in temperature. So if there is an water vapor in the air, then the evaporation is decreases. Means if more amount of water vapor in the air, then the rate of evaporation decreases. If there is less water vapor in the air, then the rate of evaporation increases. Next factor is increase of wind speed. Here, as the wind speed increases, the rate of evaporation also increases. This is because when wind speed increases, it will take the water vapors from one place to another place. So the water vapor in the area, like there is less water vapor in the area. Means when we takes the like due to wind speed, water vapor will move to the other side, and like so like due to that thing, like due to the evaporation, so due to the wind speed, the water vapor in the area will become reduced. So due to less amount of water in the area, the rate of evaporation increases. Okay. Next, we will move to the other point. Some other like evaporation also causes cooling. So this is because the particles in liquid absorb energy from surrounding to regain the energy. Means during evaporation, the particles already have absorbed the energy from the surroundings, and they have converted into vapor state. But the particles which are left behind have less energy. So these particles absorb the energy, heat energy from the surroundings, and that surrounding becomes cool. So this causes cooling effect. So some examples of cooling effect of evaporation are when we put acetone in our palm, the acetone absorbs heat from our palm as well as surroundings. So the molecules or the particles with higher energy will leave the surface and our palm become cool. So this is one example of evaporation causes cooling. Next example is that we sprinkle water on the roof or open ground after some sunny hot day. This is because when you put or sprinkle water on the roof, the latent heat of vaporization will help for the cooling of the home. So here latent heat of vaporization will come. Next is, why do we see water droplets on outer surface of glass containing ice cold water? So here we already discussed in air is a mixture of different gases. We already know that air is a mixture of different gases. It also contains water vapors. So when we already discussed that water vapors on cooling or condensation, it will convert into water. So when we keep glass containing ice cold water outside, the water droplets are formed on the surface of the glass. This is because the water vapor present in the environment or the atmosphere will touches the cold surface of the glass and they will get converted into water. That is because water droplets on the surface of the glass containing ice can be seen. So till now, anybody have doubt in this? No doubt. Okay. So now let's move to the question section. Okay. In the following experiment, in the following example, state which factor is responsible for the change of rate of evaporation and is effective. Can anyone tell? Wet to close dry faster on spreading them. Which factor is? Yeah, surface area. Yes, temperature is also there. Surface area is chosen. Okay. So let's see the answer. So increase in the surface area, like wet clothes dry faster on spreading them because of the, like when we spread the clothes, the surface area will increases. Okay. So as we know that increase in the surface area, the rate of evaporation also increases. Next. Sorry. Increase in wind speed. Okay, next. In which of the following example, like, okay, clothes dry faster on windy day. Why? Increase in wind speed. Yes, wind speed. Good. The rate of reaction increases with increase in wind speed. Next, clothes take longer time to dry on a rainy day. Why? Yeah, temperature is low, humidity is high. Yes, humid. Yeah, increase in humidity. Yes. Yeah, increase in humidity in air. Clothes dry faster in sun than in the shade. Temperature is high. Yeah. Yes, good. Niranjan, good. 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 Okay. Yeah. Okay. Can anyone have doubt in this class? If you have doubt, please ask me. No, Fatima. Okay. No. Okay, Roshan. Have you all understood this chapter? Okay, Sriraj. Yes. Okay. Okay. Okay, then thank you all. Have a nice day. Okay, thank you, Sriraj. Okay, thank you, Lakshmi. Okay.